people use reverse osmosis membranes now commercially for water to separate salt water into its components of, potable, drinkable water on one side and salt on the other. For us in carbon capture, we developed this new chemistry that when used in a composite membrane uses chemistry to pull that CO2 across. And so rather than needing all the pressure of a reverse osmosis membrane that you can imagine if you had a sieve and you're sort of pushing it through and sieving it through, you need a lot of energy. This is one that uses chemistry within the membrane itself to do that separation. So that's the novelty. And that novelty enables a very small plant because it doesn't require as much energy. So this is the breakthrough that research has been talking about for 40 years. If someone could just make something like this and industrialize it, it would be perfect for carbon capture.
Welcome back to the Decarb Connect podcast. And this week, my guest is Erica Nemser, who is the CEO of Compact Membrane Systems. And Erica is going to be talking to us a little bit about the ecosystem around point source carbon capture, but specifically some of the different technologies and where CMS sits within that. So, Erica, let me start with my traditional podcast beginning question, which is to ask you to tell us a little bit about how you arrived at this point in time, because you've got a pretty interesting background, I think, for someone that's leading and scaling up a complex tech business. So why don't you tell us a bit about the personal and professional journey that's brought you to this point in time?
Absolutely. And first off, thank you for having me. I'm really excited about this conversation.
You're welcome.
So I guess the linear look at my background is I have a PhD in economics. From there, I went to management consulting for over a decade, and from there to CMS, as we call compact membrane systems, where I now sit in the CEO seat. I think the more interesting part of that journey is not the linear path, but the thematic consistency or growth as a leader. And so I'll touch on some of those elements. The first is I love big, complex ideas. I think that's been true of me as a kid. It was true and why I went to graduate school and from there to consulting. I don't shy away. And I particularly love things where people say, that's, if not impossible, near impossible. I love to look at that and say, well, how could there be a way? What would the way be? How do we make it simpler? How do we make the impossible merely difficult and then the merely difficult into doable? So that drew me to all things complex, math, systems thinking, networks, large organizations full of human beings. And so making things happen in this environment, I find to be really compelling.
So when you think about the step change from, massive company like McKinsey, huge
Mhm,
and a very different kind of role. What was it that actually brought you into this particular corner of
mhm,
climate tech? Because you could have taken that love of the big
mhm.
complex challenge, you could have gone in a number of directions. Why this? Why carbon capture? What was it that grabbed your attention at that time?
Sure. Well, I'd say it wasn't carbon capture at that time, and I'm happy to tell the story of how we got to carbon capture. One of the things that I really liked in working with clients when I was a consultant was working on bringing technical products to a commercial launch, right? And the pathway that one needed to take as an individual within an organization, as an organization, to have the vision of what that future could look like for patients, for customers, for whatever market segment you were in, um, and then see through that multi-year pathway. And I really enjoyed it. I think I'm pretty good at it. And so I wanted to find a place where I could do that. And I really wanted an operating role. Part of what I did when I was a management consultant was also work within the consultancy on internal projects that had a more operational aspect to it. And this was a space that I would say had a dearth of small innovative companies leading the way in hardware, in climate. We'd been through clean tech 1.0 that had been rough on a lot of people. The promise was still there, But the piece that I saw work really well in other industries, which is small companies leading innovation, large companies using their immense size and stature to pull through commercialization at scale, was not something that had worked in a really grooved fashion in climate, in chemicals, in energy. And so I thought bringing my toolkit here could make a difference in a way that really was part of the game changing that people were after. And that started in chemicals and expanded to carbon capture.
Okay, good. So now we know a bit about you. We know about how
Mm-hmm,
your brain works and what's brought you into the
mm-hmm,
space. Let's then look at CMS's role in the space, because I think one of the things that sometimes catches people out when they are either industrials first looking at,
mm-hmm.
carbon capture as an option, or just people in general looking at the space, is actually how broad the ecosystem is. We have a habit of saying, oh, it's capture, it's transport, it's storage, but underneath the skin of each of those pieces is, a lot of variety. So first of all, where does CMS sit? And yeah, let's explore that ecosystem a little.
Sure. Technically, at the core of what we do, we're a separations company. That's the mechanism by which we're having our impact. Membranes, as in the name, compact membrane systems, in our case, are used to separate products, what you want from what you don't want, or two things, what you want at a purity that you need. And if we step way into the industrial landscape, it's often much easier to produce what you want than it is to separate it into the purity you need for it to be a product. The planet's full of water. Most of that is salt water, which is not the way that we want in order to consume it. And so that separation step, whether you're separating what's going to become a source of energy or what's going to become a physical material, can be energy intensive, time consuming, complex, and expensive. And so what we do is make that the opposite: easy, low energy, small, modular, bolt on, and relevant across a whole different range of application.
Okay, and so this separations business, when we look at the kind of verticals of point source carbon capture, I think it took me a good a good few months to get my head around even the basic differences, because I'm not an engineer by training. Obviously, some of the industrials, the people
Mhm,
within it leading decarbonisation, some of them come from that classic and engineering background. Many do not. Many come from more of sustainability or other
mhm.
types of backgrounds. What's your experience of kind of talking to people about those differences, and then, what a membrane solution offers to what is it that industrials usually come to that conversation understanding, and what do they not necessarily understand?
Sure. So I'm a big advocate for the customer's value proposition and vantage point, which is often not what's inside the black box and how it works and why it's so cool. Engineers often love that, and I love that engineers love that, and we have great engineers who love those things. What I love is talking to customers about what are you trying to do and what's the easiest way to get to that destination, right? And for most of our customers, they don't CO2 is not a value stream for them, meaning they're on board with decarbonization. They want to decarbonize their part of industrial landscape, whether that's steel or cement or hydrogen or something else. But more often than not, they don't have a particular use for the CO2. It's for them, it's a waste stream, it's trash, right? They don't want it to go up into the atmosphere, which is what's happening now, but they don't particularly want to manage it. And the reason I bring this up, back to your question, is what they want is a total solution, not a technology. They want a solution, and they want one that's easy to use, easy to integrate, easy to operate, works within their plan in the space that they have with the power they're able to access. And that becomes the jumping off point for a conversation with them about technology. And the other important component of that is timeline. Everyone recognizes that there are new technologies out there. You brought some of them up. They're looking at decarbonizing over years and then decades, right? So they could change their entire unit operations in the future, and then they have things that they'd like to decarbonize this year. So we talk about it in those. If you want to install well-known technology that's been utilized in other places that may or may not have the ideal profile for you in terms of other metrics of usability and cost, the technology available now is Amines. It's been used in industry for decades. Many people can manufacture amine systems for you and put one in place. The challenge for amine systems, and why we are here and other companies are also pursuing carbon capture with MOFs and other technology, is because the overall profile of amines is probably not going to reach every single application. It does not have the either energy consumption or emissions profile or usability in a plant that customers are looking for. So we come to this and say, look, there's a $1 trillion market that's looking for something that's easy to use, bolt on, simple, operable, low energy, fully electrified, that can work within the existing plant. And that's the value proposition that we offer to customers. I would say the other way in which we're unique and sit between kind of two ends of the spectrum are the technology innovation. It has a lot of promise. It's very cool. It's in the lab. If it scales, it's going to be amazing, right? That's one end of the spectrum. And then the other is the one that I pointed out, amines. It's known, it's well produced. It's for those people who live in the TRL world. It's TRL 9 technology, meaning it's fully commercial technology. One of the things that compact membrane systems has a history of, and we're very good at, is industrialization and saying, what are the hard things that you're going to choose to do, and what's the platform you're going to work on in order to manufacture something at scale that industry is ready to accept. We have commercial membrane products. We have commercial membrane manufacturing. We know how to do those things. And so that's another piece of uniqueness that matters to customers. And coming back to our original part of the conversation on, we didn't necessarily start with carbon capture as one of our initial launch application for our technology platform, which I know we'll talk about. And part of that was because, 5 years ago, people told us that carbon capture was interesting, but not relevant in the next 20 years, that the market wasn't going to move that fast. So we would be standing here with a product that didn't have a market. And that's, from a market standpoint, been very pleasant to see. I know there are lots of doom and gloom about decarbonization, how fast it's going to go, and what's going on in the ecosystem. And I don't want to dismiss that at all. But we did see a turn in the market in the last couple of years that enabled us to accelerate the development of this particular product.
Yeah, I think we're seeing that too through our members. I mean, the kinds of conversations that we hear people talk about in the membership or at events, of course, there are still companies that are trying to work out the how and the what and the very early stage plans for decarb, but more and more companies are moving fast through the kind of pilot to roll out to multiple sites planning phase. And it definitely feels like it's a market right on the cusp of some very interesting change.
Mm-hmm.
So you're obviously pretty confident, as you should be as a CEO of a company, very confident about the technology. Talk to me a bit about the scalability of it and taking on major industrial sources of emissions. One of the things we're going to talk about later is, two of your client projects, but what is it about either the nature of your platform or the nature of technology that lends itself to that scale? And I guess part of that question is a nod to the fact that we know and we hear from some industrials that some of the challenges for them are around particular constituent particles or issues with their stream, of CO2. Like, so tell me a bit about membrane technology, your membrane technology. What is it doing that allows it to scale? And tell me something about that.
Sure. So I'll talk about it in two parts. One is, what's the novel chemistry that's doing the separation here, that's the breakthrough, right? Because if it had been invented before, somebody would already have this out there. So there is a novel piece of that. And then the second piece I'll talk about is, why do we see scalability as a challenge, but a very manageable one, given that we manufacture now. So we're not looking at it as an if, but as a when. The separation uses a facilitated transport membrane. And so membranes are, you can think of membranes like balloons, right? Gas is going to retain some things and other things are going to go through. So your helium balloon deflates over time as that helium escapes the balloon. Okay. And so a great membrane for us is the one that holds back the materials that you don't want to go through. And then the other ones that you want to separate go through easily, rapidly with low energy, et cetera. That's true in all spaces where you're using membranes and separations. People use reverse osmosis membranes now commercially for water to separate salt water into its components of, potable, drinkable water on one side and salt on the other. For us in carbon capture, we developed this new chemistry that when used in a composite membrane uses chemistry to pull that CO2 across. And so rather than needing all the pressure of a reverse osmosis membrane that you can imagine if you had a sieve and you're sort of pushing it through and sieving it through, you need a lot of energy. This is one that uses chemistry within the membrane itself to do that separation. So that's the novelty. And that novelty enables a very small plant because it doesn't require as much energy and it has very high flow rates. So a lot of gas goes through a very small membrane system. So this is the breakthrough that research has been talking about for 40 years. If someone could just industrialize this, it would be make something like this and industrialize it. It would be perfect for carbon capture because it's got a lot of gas, right? These tend to be small sources of CO2 and it's at very low pressure. It's at atmospheric pressure. So how do you do that inexpensively? You don't add a lot of money into the system. And that's what we've done. And that's going to be true of innovation in general, is going to be how do we take that cost out? How do we make it manufacturable? The advantage we have on manufacturability is that we make composite membranes now with very similar chemistries to this, not the exact same thing because it's not the unlock. And we do that. Other membrane manufacturing processes do that. And so we're not having to invent a way to make membranes in order to solve carbon capture with membrane solution. Okay. So we're not having to say, what if someone could invent a way to make this 100 times bigger? People know how to make the membranes. We know how to make membranes. And so it's a matter of stepping through the manufacturing steps of doing that. But it's not about inventing a new manufacturing pathway. And that's what's been enabled us to scale the membranes, 100x in size in the last several months, right? Not the last several years on our manufacturing platform that we use for commercial membranes now. So they're not as large as we'd like them to be now, but we know what that looks like and we know how to do that.
That's really interesting. I was listening to another podcast over the weekend that focused on first of a kind and the challenge of investing in folk plants. So I guess looking at this, the first of a kind element is purely that the chemistry pull push that you described in the membrane. It's not in the actual architecture of the solution itself. Which must also please investors as you're going out to market.
Yes, it pleases us indeed, because if you can think about it, at the end of the day, the membrane's like a filter cartridge, right? You're going to run gas through it, and depending on how big your system is, that will tell you how many filter cartridges you need and in what sequence, right? How many in each stage and in how many in series. And then it's things that people know how to do, right? There's piping and moving gas around and heat exchangers, et cetera. So we're going to face the same, that's why I said, we're going to face the same challenge of a first of a kind plant in terms of, is the sizing of everything right? And does it work together the way we want? But those are also known solutions to known problems.
I just want to take this opportunity to thank our production partner and sponsor, Jano Media, for their support in delivering the Decarb Connect podcast. Over the last few years, they've helped us to facilitate great conversations that connect us with our audience, and their skills and expertise mean that we get to concentrate exclusively on generating the content, the conversations that engage, inform, and inspire. Okay, well, so we sort of had a little look at what's going on with CMS under under the hood, if you like, or
Mm-hmm.
under the bonnet, if you're
Mm-hmm.
European.
Mm-hmm.
Um, when you think about when you're presenting this to customers, and I guess you partly already answered this, but the question was going to be, are customers more focused on price or on stage development, TRL? But I assume the answer is, with you, that they're more worried about how easy it is to build in and the cost of energy, perhaps. I don't know. But what's your sense of how customers react to the kind of pros and cons of the phase that you're in at the moment?
The advantage we have is the flip side of the challenge that each of these industries or industry players has, which is they're trying to decarbonize an entire enterprise, which is multiple plants, and within each plant, multiple unit operations, sources of CO2. Okay. And so they're looking at a transition plan that's not a single event. It's not, we're going to put solar panels in and that's going to solve 99% of our problems. They've got many different types of issues, but that creates many different sources of opportunity. If a company wants to put carbon capture in this year, that's existing technology. If they want to put a membrane plant in with us in 2026 or 2027 or 2028, we are here for that. We are here, right? And so for many of them, the idea and the appeal of this is commercial technology, this will be commercial technology available before 2030, right? With the value proposition of low energy consumption, small footprint, and all of the features that make it practicable in an industrial facility, that's exciting to them in a multi-generational plan.
Well, that kind of leads me neatly into the next question, because as you've said, industrials come to you, they come to anyone who's in
Mm-hmm.
this sphere, kind of, and they're looking at a range of issues from timeline to investment to different types of plants, different locations, everything. But what they're all secretly hoping for, and I'm oversimplifying, but they are secretly hoping that there is the silver bullet.
Mm-hmm.
Clearly, that really doesn't exist. But I'm interested in your perspective on this. When you encounter that, or that kind of idea and that mindset around decarb, how do you deal with it? And yeah, let's leave it at that. How do you deal with that sort of mentality, that seeking of the one thing that's suddenly going to make all of this go away?
Sure. I'd say that's ultimately human. As humans, we are focused on what's the fastest, easiest, best way for me to get to the answer. And if there were a silver bullet and I could just find it, I could solve it. And that was a little bit of the thinking maybe that people had 5 or 6 years ago. And it's starting to move away from that in the sense that if anyone asked us what would be the ideal transportation, we'd say, well, it should be small and should go on a sidewalk, right? It should replace walking and a car and a plane and a train and be low, right? We can describe what ideal would be. The challenge is it doesn't exist. And so we accept in other domains that there are multiple solutions. They coexist next to each other. They solve different aspects of the challenge. We all still walk, or many of us and most of us still walk as the best solution for many situations. And I think carbon capture is no different in that. Folks are starting to realize that the ideal solution for a particular problem, whether that problem is in an industry or a unit operation or a specific application, can vary depending on what it is. And you brought up an important one, which is what's the price of energy that folks face and what are they going to face over time and how much energy will they be able to access? We have a solution that enables us to optimize for that. If you have low energy, we take advantage of that. And if you have expensive energy, we size the system to make a trade-off with membranes to do that. But that's part of the larger question of a lot of technologies will coexist next to each other in this market because there are so many different applications that are so very different. And they'll coexist within one solution also. One of the things that we look at in membranes in general are good at is working in what I call a hybrid system, meaning the system itself for any one application incorporates multiple technologies in order to do the work in the most cost energy efficient fashion. Anyone who, or many folks who are now using natural gas that was from biogas, right? That was biogenically generated and then separated either from landfill or from farm or elsewhere, or they may not know it, but they're benefiting from a hybrid system like that. And we see that as a part of our future as well, deploying this for customers in conjunction with other technologies that other people are working on. So I don't think of that as a transition, or there'll be winners and losers, but there'll be winners across a whole range of technology platforms.
Okay, well, let's look at this in the context of a couple of the partnerships that you've developed with really impressive big brand companies. One that we're going to talk about is Voestalpine, and one is RHI Magnesita. So I'm wondering if we can go through like 4 or 5 questions about these and look comparatively, if that doesn't become a total brain swirl. So let's have a look first of all. Like how did those projects come to you? When you think of Voestalpine, you think of RHI Magnesita. How did those come to you? And then how do their timelines or goals, how are they similar or different?
Sure. So both of those we met through the Verbund X Accelerator. And so this was accelerator in Austria of Austrian companies. And the purpose was to connect large industrial companies that were committed to decarbonization in their across their plants and across their enterprise with technology providers so that we could match those two things together, right? They could see into the innovation pipeline and access that earlier than others. And the technology providers like CMS could utilize those plants as test beds. Okay. Voestalpine is in steel, RHI Magnesita is a kiln process, right? And those are key applications for us because we recognize that the value proposition of our membranes in general, our membranes in particular, is high in steel as well as in kiln processes like theirs and like cement.
And then in terms of their relative goals for the partnership, how would you compare and contrast those?
I would say they're similar in that, and this is true of the companies that we saw at the Verbund X Accelerator, is they largely what I would describe as pre-qualified, meaning they had identified what their carbon footprint is. They had identified their goals. They had identified their streams. They had the right internal participants from operations and business units, et cetera, together in a way that they could make decisions and move forward and understand what the challenges were and the opportunities on their side. And that was exceptional. They're different in their streams are different, right? A kiln process is inherently different than a steel plant. If you just look at those industries in general, a steel plant's the size of a city, right? It's square kilometers. It has a massive number of unit operations, a large number of CO2 emission streams, and a variety of different decarbonization challenges, right? And as well as a lot of different streams of materials moving through there in a very complex fashion. And refractory materials and cement plants tend to be much smaller and are much more constrained in a footprint.
To what extent, like, or rather, how do the actual gases that you're tackling, how do they differ? I mean, this is where listeners will know my knowledge and expertise reaches a very large, sizable brick wall. But I know that certain types of streams have different toxins or different metals, whatever it might be in it. So how do they differ in that way? And or does it matter with membrane technology?
It does matter. So they differ in CO2 concentration is one big way. Steel emissions tend to be higher than cement. right? And so that's a benefit for us and for other technologies, that's less of a lift. You're dealing with often CO2 in the 20% concentration. So concentrating that up, whether you want to take it to utilization stage, like what we'd call a 60% CO2 concentration stream, or all the way to pipeline, which is more like 95%, that lift is not as far. So that's a one of the biggest differentiating factors. And then, as you said, the materials in those streams, whether it's CO, and they can vary across the plants, and the physical debris, right? Because that's one of the things that you worry about in a membrane. Is in our membranes, we worry less about the chemistry contamination. We validate the chemistry contamination, but we do worry about physically plugging the material. And again, the filter cartridge analogy is here. If you put a bunch of physical stuff into that, it's not going to be good. So the pre-filtration makes a big difference, right? And that's, for example, a kiln process. We'd be more concerned about those.
Okay. And you've already mentioned, obviously, the sites differ in scale.
Mm-hmm.
Are there, so what does that actually mean? What does that, or and any of the other differences in the sites mean in practical terms for project management for you? If you're coming on site, does the actual solution itself differ in size for those different projects?
Sure. It differs in the number of systems and the size of those systems and the constraints on the system. So I'd say generically in a kiln process, you're talking about a small footprint, something the size of a, bay of a garage or 2 bays of a garage. So, and needing to put one of those in for one kiln, and there may only be one, and that's a sort of single operation. In a steel plant, you could have 25 different CO2 streams. So now you're talking about using the modularity of a membrane system to address multiple different streams, where you have small membrane systems in different locations, where you might not be as constrained around, okay, it really needs to fit in this small footprint because this is the only footprint available. There may be more space, but then the challenge is going to be, which ones are you going to do first? What's the right way to deploy against 25 different streams? Is it 25 different systems, and you pull the CO2 back together, and it's a much larger project?
Okay. And then last comparator question is, over what period of time have those projects run, and how has that volume changed? The volume, sorry, of the streams that you're tackling. What's that scale difference been over time?
In those partnerships, the goal was and it remains, we're first to test those streams and validate the separation and validate some of that potential contamination and poison work that you were talking about earlier. And those initial rigs will go, and they're what we call lab scale. They're with very small membrane modules, and they'll be going out in this early part of 2024. And then the idea is that they can move to larger demonstration plants with a commercial size membrane module as the next step.
Okay, great. All right. Well, I think always useful to hear about examples of projects, because sometimes whether you're an experienced industrial leader in this space or not, whether you're an experienced investor in this space or not, it can be hard to grasp. So I think really interesting to have that comparison between two different types of clients, different sites. So moving into the kind of end stage of our discussion then, Erica, we talked before we came into the recording about the fact that CMS is obviously growing and it's about to go through a rebrand. Give us a feel for where you stand in terms of the stage of growth you're at, plans for the future for the business, and also why the rebrand now?
Sure. So we're excited about seeing the carbon capture rigs go out into the field with each of our pilot partners this year, finishing up the demonstration of the technology in the olefin separation, which puts it into commercial territory, and scaling up the production of our carbon capture modules to full commercial modules. Those are all on our docket. And the rebrand, I would say, is emblematic of that transition of the organization from more an R&D focused to a commercial enterprise in those new spaces. And the Ardent name, we thought, is emblematic of us really leaning into the industrial decarbonization and the shift in the world as it transitions to a new way of producing energy and producing materials. And we're ardently committed to that.
Nice. Good use of brand verbiage. Well done. So that the Ardent brand, you're hoping for release, what, Q2 of 2024? Does that sound about right?
Yes, end of Q1, beginning of Q2 of 2024.
And how about, I mean, the question I'm always asking tech companies or solution companies when they come on is about their investment and funding rounds. Is that something that's a focus for you right now, or are you more in kind of the scale up with what you have right now? What phase are you in that context?
Sure. We're very focused on those milestones. We recognize that that is what the market is looking for. And I say market generally, whether it's investors, customers, partners, are delivering those milestones. So that's where our focus is.
Great. Well, I feel like, Erica, we need to pre-plan for a kind of a podcast update when you're in that kind of later stage of some of those projects, when you're going up to kind of bigger volumes of stream and things like that. It'd be really interesting to come back and hear how they've developed and how you've kind of, inevitably there'll be challenges, how you've overcome that, but also what some of the wins have been. So hopefully we'll have you back later this year or early next to do an update on those and other projects that you develop. But in the meantime, thank you. Thanks for talking through not just your product, not just your solution, but the ecosystem and those projects as well. Great to have you on board.
Thank you very much. I appreciate the time and the opportunity. It would be my pleasure to come back in the future.
At Jano Media, we recognise that great content has the power to create impactful and positive change for lives and society. Whether that's video, live streams, photography or podcasts, partnering with us will enable you to harness the power of content to engage, inform and inspire. Reach out to us today.